Hello roboticists. Today we're going to be going over how to make a drawing for a custom part. In this case we've done a custom example of a VersaFrame. So this is the VersaFrame stock. We get it from Vex. If you scroll down they have a bunch of options, but then they also have these drawings of the parts themselves, and that is basically what we're going to be making. Now we are CADing up the thick VersaFrame extrusion. That's this part number 217-4104. And there are a couple things that I'd go over with this drawing. One, I don't love the layout for this particular version. For example, it does the front view, the right view, and the bottom view. I generally prefer to have the isometric view in the upper right hand corner and then run front, top, and right. But it's, that's a preference of mine. The thing that I do like is that they've got these long break lines, and we'll go over how that's a problem when we make it. This is kind of the guidance that we used for making the VersaFrame part. So we've got the VersaFrame part in our CAD, but one thing you're going to notice is that the holes are different than that which were in the drawing. So if we take a look, there's actually kind of three versions of the Vex VersaFrame at this point. There's, in general, we'll use a thin piece. This one actually ends up being thin. It is a 40 thousandths thick VersaFrame, and previously the holes were offset on that one and on all four sides, but now they are not offset, but they're still on all four sides. And the thick version, which this piece is, was originally had a side that had no holes, and then a side with holes. Now all sides have holes, and the holes align. They're not offset, so the top and side holes are the same. So that's actually what we've CADed here, where the holes here and here are offset ½ an inch and then an inch apart for all of the holes, and that is what we've CADed, and this is what we seem to get when we buy it. So that's the disclaimer that there's some different options for the way you receive this. This is the way that we've received them the most recently. So first thing I want to do is talk about our sides. So we created this extrusion with our Z and X plane, or Z and X axis set up, with the top looking down here, where then our origin is in the back left hand corner. Now this is very useful with respect to CAM. So if we're going to end up doing machining on the top of this, then in general we would touch off that back corner and set that to our origin, and then set up all of our measurements from there, because when it is in the mill, we're going to have that back left-hand corner. The back side is going to be against the fixed side of the jaw on the mill, and then the, and then however far left we put it, that'll be kind of our X0, and so to the right is our X positive, and then down towards us is our Y negative. And then up and down with respect to the part is going to be the Z axis. So up and down. Okay, so that's how we've got it laid out in our CAD file. However, when we do that, then we end up with the end of the part being considered the front, which is not ideal for us. So in this case, we would prefer to have the front have more information about the overall dimensions of the part, and so we're going to redefine the front as the first step here. So if I click on my view cube on the right hand side, I'm going to right click on this and say set current view as front. Now when I go to my home position, I've got left, front, and top, and that is all presented as such. So, and next I'm going to go ahead and I'm going to create a drawing. So if I click up under design, drop down to drawing and say drawing from design, then that's going to give me an option. Now for the drawing itself, we actually use, we're going to use a template. So rather than we've imported a template for our use, and we've set it up, kind of the way we like it. So I'm going to go ahead and change the template from scratch to Lindblom drawing, and then the contents are the full assembly, and we'll click OK. And then we'll also go ahead and we'll put a link to our drawing file, and you guys can in the comments section so that other people can download and then modify it as they want. So the first thing I'm going to do is I'm going to go ahead and place the front view. I want to change the size of this to maximize how much will fit on the page. Looks like I could probably get to 3:1 or 1:3 reasonably. So I'll go ahead and place the front view there. I will place and then I'm going to make sure, click OK. That sets up the front view. Then I'm going to go ahead and create my projected views. So up top, click projected, click on this, place a top view, and then move to the right and place a right view. And then click the little check mark. And that is done. So now I want to go ahead and place my isometric view. So I'll go ahead and pick this base again. Then this time I'll change this to, again, 3. I want to change the orientation to be, say, home view. Now that's a little long, so actually, let's go ahead and switch this over to northeast isometric. So this actually shows me the correct orientation. I'm going to turn on my shading in this case. So now looking at this, this is the front, this is the right, and that is the top. 1:3, that looks good. So we'll click OK. So now I've got my isometric, and I've got each of my views here, and then the end view. Now we're going to go ahead and we're going to place our dimensions. I want to start off doing the overall length of this object. So in this case, we are 28 inches long. That's good. Then I'm going to go ahead and do the height of the object, which is 1 inch. And then I'll do the depth of the object, which is 1 inch. And now I have the primary dimensions of this extrusion. Now, the biggest issue right now with Fusion 360's drawings is that they do not have a broken line or a broken view. So what that means is if we look at the Vex drawing, this zigzag line, what this does is it allows us to basically truncate a view of an object, saying that this is uniform all the way to the end. And so we're just going to not show it to scale as far as the length goes. We're going to break it. And so the zigzag lines here allows us to have a much shorter length. And then it also allows us to have a scaled larger view in this case. So this whole thing is bigger because it can be to scale and fit on the page with the long break. So we can't do that. Currently, it is a 2020 feature that they are adding, but today happens to be the last day of 2020, so it seems like they are a little behind. That's all right. What we'll end up doing to kind of help us with this is we'll end up using our detail views. So in this case, we go up to here and we select detail view, and we're going to first do a detailed view of the end. And so we'll capture this by clicking on the center, then clicking again, and then getting this detailed view. And then in this case, we're going to go up, we'll place it, and then we're going to scale this to be, let's try 2 to 1, or at least 1 to 1. All right. And so what that does for us is now it allows us to go ahead and apply the dimensions that would be to this, that would end up being really small, in a larger format. So for our height dimension and our depth, we've already got our 1 inch and 1 inch. So we don't really need that. If we want, we could take a look at the other drawing and see they're identifying the wall thickness. They also put the overall dimensions there. That is another option. So instead of drawing it at the end of the extrusion here, they put it on their drawing. So in this case, perhaps it makes sense for us to do that as well. So I'm going to go ahead and delete this and delete this one. And then I'm going to apply those dimensions on the detailed view. So here, click 1 inch, here, click 1 inch, and then in this case, we'll go ahead and we'll do the thickness. 0.1 inch, and the thickness here. Maybe instead we'll do the thickness of 0.1, and then we'll add like a leader with text. So something along the lines like this, where we say uniform thickness. All right, so now we have a note that says it's uniformly thick. we have that dimension, we have the height and width of the extrusion, and that is all applied in this detailed view. All right, so we'll click OK. Now we're going to go ahead and do a detailed view of this section so that we can basically show the holes and everything for the extrusion. So we'll click detailed view again. Click on this object. You always click kind of the center of where you want the detailed circle to be. So I'm going to go to this other hole and then give myself that much room. And in this case, let's change it to 1:1. And I should be able to place that here. And click OK. So now I have a detailed view of the object. I need to move this note, here. That's actually on the page. And also I need to move this note onto here. Okay. So now that I have this detailed view, I'm going to go ahead and add additional dimensions. The first thing I want to do is add center marks to each of the holes. So here. Go ahead and just do those 5. The next thing that I'm going to do is I'm going to dimension to the center line from the top edge. So here to here, and then set that dimension there. In this case, I'm going to try to slide this out just a touch more. Move this guy closer. All right, so now I have the offset for the hole. And now the last thing I'm going to do is I'm going to end up with my chain dimensions for each of these holes. So I first click and add a dimension from the edge to my center line here and pull that up. And then I'm going to move this guy to the center. And now I'm going to go to dimensions and select chain dimension. And in this case, I'll select this dimension and I'm going to then pick the next line and the next line and the next line and the next line. And then I will right click and pick OK. So now I have these chain dimensions showing that each of these holes is 1 inch apart. And now the last thing that I need to do is I want to go ahead and provide a dimension for the hole size. So I will click on the edge of the hole and pull my leader line. Actually, that ended up being the wrong way. So dimension. And then I want to come off at an angle, click, and now I have the dimension for that circle. If I hit escape, then I double click, I can actually then add a note that says 0.064 for all through holes. And so now that kind of covers all of the different holes. It gives us our chain dimensions, and we are, we might add one other note, right here, just to say all holes 1 inch spacing. I can change the size, maybe make it 1.5, a little bit bigger, and then click. All right, so now I have my drawing. I have the detailed view that gives me the thickness and the dimensions. I have a detailed view down here to show where all the holes are. And then I have the overall length as well as then the depth and height. The only other thing that I'd probably add is then I'll update the notes up top to kind of mention the specifics of this part and how it is made. So in this case, I can, set the material. In this case, I believe, look at the other drawing, it is 6160 T6 aluminum. So I'll go back to Fusion, material. We've got that. Then we'll take a look at the other notes. In this case, we could say that this piece is made from the from this part number. So we're using this as our raw stock, this length of 59 inches. So we'll go ahead and instead of talking about the coding, let's say cut from (217-4104) and grab the (59-inch) VersaFrame stock. (59 inches). And then in this case, remove all burrs and sharp edges and ensure cut end lines with gusset edge. So it's really important that the end of the extrusion, we're going to have a gusset on it, and if it's too long and it butts up against another piece, then if this end dimension isn't pretty much right on, then we'll end up with a misalignment of the holes. So that final note is talking about that. So in this case, Then we can fill out our revision. So let's call this Rev 1, or this is, it's actually under revision 2. Description, standard, VersaFrame. And then I'll go ahead and put the date. So we're 12/31. And then we'll need to have somebody else probably approve it, but for now we'll do TB1. And so this is our rev. It matches with the revision. Oh, actually it should be Rev 3. So it matches the revision of the drawing of the actual part number. Or we could say this is the very first time we're making the drawing and make it Rev 1. I don't know. We haven't decided that much on the drawing numbers. We'll call it Rev 1. And then version 3. That way we've got the drawing rev and the model version. That makes sense to me. Here's our team number. Here's the name of the stock there. Title of our part. And it looks pretty darn good. So that's how we create our drawing. I hope you have a good day. Don't forget to save. And then we've got the drawing we'll show over here. You'll also see if you open this up, there'll be a list of drawings that then you can open through this page. And that is it. Now you can have a good day. Rock on.